So today we're going to start looking at graphs. So I'm going to go ahead and just read the part of the packet to you. A helpful way to represent motion is often with a graph. Not only does the graph show a scientist a visual representation of the motion, but certain values can also be derived from the graph by finding the slope of the graph. And that is what we're going to do today. We're going to derive certain values by using the slope. In calculus, we call finding the graph differentiation, and we call finding the area integration. The first type of graph that we will look at is the displacement versus time graph. So we're going to look at displacement versus time. In displacement versus time graph, the slope of the graph represents the velocity of the object. This is important to remember. You will see this question on test quizzes, and you'll be asked to calculate the velocity using a graph, and you'll need to know that you need to find the slope. The slope can be found by calculating the rise over the run. So just like in math class, we say slope, we use the letter M, is the rise over the run. And if you remember, rise up and down, that's the y-axis, so it's y2 minus y1. Over the run is the x-axis, so it's x2 minus x1. So that's our equation for finding the slope. If the line is going up, it is a positive slope, which means it's a positive velocity, okay? Which means in our problems, the object is moving to the right, okay? Or up, but in the problems we're going to be doing to the right, okay? In the positive direction. If the line is going down, it's a negative slope or velocity, which means that the object is moving to the left. Okay, a positive velocity simply means it's traveling to the right, and a negative velocity simply means the object is traveling to the left. So down below it asks us to find the velocity for each section of the graph. Be sure to give a positive or negative sign. So here's our graph, and then down below we've got our space for our calculations. Okay, got my equation up there, so we'll be able to look at that if we need. So section A, so this is section A right here, okay, that whole section. So I need to find the slope of that line. It's a straight line for that portion, so I can pick any 2 points. I'm going to choose the starting and ending points. I'm going over 0, and then down 10, and then this was over 2, and up 10, okay. I'll call this point 1, that point 2. So point 2 y-coordinate is 10, minus point 1's y-coordinate is negative 10, over point 2's x-coordinate is 2, minus point 1's x-coordinate was 0. Okay? So 10 minus negative 10 is 20, and 2 minus 0 is 2. 20 divided by 2 is 10, and it is a positive 10. And the slope represents the velocity. One way to remember that is if you look at the slope, the x-axis is time in seconds. So on the bottom, my units would be seconds. On the y-axis, it's the displacement, and the units are meters. So my units here would be meters per second, and I know that meters per second is a unit for slope. For description of motion, we're just going to say we know it's a positive 10 meters per second, so we know it's moving at 10 meters per second to the right. Okay, I'm going to go ahead and work on section B with you and section C as well. So here's section B. And again, it's a nice straight line. I can use any 2 points. I'm going to go ahead and use the first because I've already got it labeled. And then I'll use the last, which I guess that's 4, that's 6, this is probably 5, so over 5, and up 10. Okay, I'm going to call this point 2. So this would be x2, y2. This would be x1, y1. I'm going to call that point 1 this time. And then we'll go ahead and move down so you can see a little bit. So I would have y2 is 10 minus y1 is also 10 over x2 is 5 minus x1 is 2. So I end up with 0 over 3. So 0 meters per second. Okay, 0 is not positive or negative, so I'm not moving to the right or the left. And I'm going 0. That means I'm stopped. So you could say stop, or you could say not moving, okay? They mean the same thing. All right. Then let's look at this last section. So in this last section, again, any 2 points, but I'm going to just choose the first and the last, especially since I have the first labeled already. So this is over 10 and up 0. Okay, I'll call this x2, y2, which means that this is now x1 for the green segment and y1 for the green segment. Okay, so y2 is 0 and y1 was 10, so I have 0 minus 10 over. x2 is 10, y2 is 5, so I have 10 minus 5 on the bottom. So on the top, 0 minus 10 is negative 10. 10 minus 5 is positive 5. Negative 10 divided by positive 5 is negative 2. Again, my units are meters per second because the top was measured in meters, the bottom in seconds. I know it's a velocity. And the negative simply means we're going left. So I'm going 2 meters per second left. Okay, I could write to the left, but I'm just going to go 2 meters per second left. All right, so we've got our next page. And on this page, we are asked to do the same thing. Okay, so we've got, except there's 4 different sections. So instead of 3, we've got an A, a B, a C, and a D. Okay, so I am going to leave you to do those ones on your own. Okay, so go ahead, using the slope of each segment of the graph, find the velocity, be sure to include the positive or negative, and then write how fast it's going and the direction that it's moving in the description of motion.